vertical line test. Okay, so this is x equals 2, and it's not a function. So the statement is false because we found one example where it doesn't work. Okay, for 36, they want turning points, domain, range, and behavior, end behavior. Okay, so I know it's missing the word end, but it's the end behavior. So we need to find the leading term. So we take x, x, and x. This is x cubed. Okay, so this tells me that the degree of this polynomial is 3. So the turning points, I'll just put TP, is n minus 1, with n being the degree, so 3 minus 1 is 2. Okay, then we have the domain. It's all reals. Every polynomial has a domain of all reals. Okay, that's how you write all reals in interval notation. The range, I'll hold off on that one for a little bit. And let's take a look at end behaviors first. Now, because it's a cubic function, this is a down up, right? So this is a down up, and you would say, as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. Okay, that's how you would write it mathematically. Okay, and then because the ends go in opposite directions, because it's going to be something like this, then the range is also all reals. Okay. Okay, so for this one we take x squared, x, and x, multiply those together to give us the leading term. So this would be an x to the 4th problem. So with 4th degree, you do 4 minus 1, so that's 3 maximum turning points in this function. It could be less, but 3 is the maximum. The domain, it's a polynomial, so the domain is all reals. The end behavior, well, when the degree is even and a is positive, see how there's nothing in front of the x, it's positive, then it's an up, up. Okay, so you would say, as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to infinity. Okay, because both ends go up. So you guys have to know what this means, but you guys also have to know how to write it like that. And for the range, I would need a graphing calculator to get like the lowest value of y. So that one, I'll get back to you on that one, okay? Because I don't have the Desmos available right now. Okay, so we'll put that on hold. Okay, 38. I've got x squared and x squared because there's a 2 outside of parentheses. So this is another 4th power quartic function. The turning points, 4 minus 1, so that it has a maximum of 3 turning points. Okay, the domain is all reals. And because it's an up, up, because again a is positive on this one, we write as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to infinity. And this is another one where I'm going to have to come back after I sketch it or graph it with Desmos. Okay, so this one is a 2nd degree, a quadratic. So turning points, we would say 2 minus 1, so there's 1 turning point. Domain is all reals. End behavior, because it's even degree and a positive a, this is another up, up. So the answer would be as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to infinity. Okay, because both ends go up. The range, we can figure out the range on this one because I know that the h is 0 and the k is 3, and I know that it opens up. So then I know that at 3 I'm going to have the vertex for this parabola, and it's going to open up like that. Okay, a lot nicer than that, but that's the idea. So the range would be from 3 to infinity, and it includes the point 3, the number 3. Okay, so that would be the range. Okay, so for number 40, you have to write the equation assuming again that a is 1 or negative 1. Okay, notice the y-axis is not even labeled. Okay, because we're focusing in on the zeros, their multiplicity, and the end behavior. Okay, so because a is a down-down, I know that, and I'll use f of x. I know that the a has to be negative. Okay, I also know that the degree has to be even because it's a down-down. Okay, so I'm going to go through and do each factor. So if the first one would be x, since the first 0 here is negative 3, I know that this is going to be plus 3. And it crosses, so the multiplicity is odd. For the next one, right here, it's x plus 1. The multiplicity is even because it bounces off, it's tangent. So I'm going to put a 2 right here. And then for the third one, this one over here is a positive 2, so it's x minus 2. The graph crosses through to 0, so the multiplicity is odd. Okay, so if I look at all my x's and I multiply together, I get x to the 4th, which makes sense because I knew I needed an even degree. It has 1, 2, 3 turning points, so 4 minus 1 is 3. The degree is 4, 4 minus 1, 3, it matches. So here's the answer for that one. For B, it's a down-up, so I know A is positive, and I know the degree is odd because it's a down-up, because the ends are going in opposite directions. So f of x equals, I know A is positive, so I'm going to put parentheses, x plus 4, and then x minus 0 or plus 0, it's because see the intercept is 0. You don't have to actually even put a 0. I mean, yeah, you don't. You could just leave x. And so x, because it bounces off at 0, I know the multiplicity is even. And if I look at my final function, x times x squared is x cubed. That's what I expected, right? A cubic function is odd. The endpoints here are opposite directions. 3 minus 1 is 2, so I've got 1 turning point and 2 turning points. So all that matches, all that fits. So here's the final answer right here.